Let us continue carbonyl compounds. In the carbonyl compounds, we will discuss Novi-Nagel reaction. Novi-Nagel reaction we are taking. Novi-Nagel reaction. In the Novi-Nagel reaction, what we have to take in the sense, we have to take a aldehyde or ketone which is not having alpha hydrogen. Aldehyde or ketone which is not having alpha hydrogen, we have to take. It is aldehyde or ketone which is not having alpha hydrogen, we have to take. Then we have to take a methylene group flanked by two electron withdrawing groups. Methylene group flanked by two electron withdrawing groups you have to take. Methylene group is flanked by two electron withdrawing groups you have to take. Okay. It is methylene group. It is having one electron withdrawing group here, one electron group here. Like this compound we have to take. Here taken compound name is what in the sense malonic acid. Taken compound name is what in the sense malonic acid we can. Okay. Then this is treated with what in the sense weak base. Here weak base we are taking. What is a weak base in the sense? We can take pyridine, we can take pyridine. Pyridine formula is like this. Pyridine formula is like this. Then we can take a piperidine. Piperidine we can take. Piperidine formula is what in the sense? Piperidine formula here NH. Piperidine we can take. Otherwise we can take ammonia in ethanol. Ammonia in ethanol we can take. Okay, weak base in the sense any one we can take. Sorry. So what is obtained now? That we'll see. What is obtained in the presence of weak base? What is obtained? Okay. Now this weak base makes this methylene group carbanion. Sir, how this weak base is making methylene group carbanion? That we'll see. Here CH2 will take. Now weak base will take, for example, pyridine. So we are taking pyridine. It is having lone pair. Now this pyridine, this nitrogen is abstracting this proton. This bond is shifting to this edge. This hydrogen is having higher acidic nature. Why? Because this electron withdrawing group makes this as higher acidic nature. This electron withdrawing group also makes this as higher acidic nature. Because of two electron withdrawing groups, this hydrogen is having higher acidic nature, which is abstracted by weak base. Weak base itself, proton can be abstracted. This weak base itself is abstracting this proton in the sense this proton will have how much acidic nature you see. Okay. Now this pyridine becomes a pyridinium ion. Pyridine becomes pyridinium ion and leaves. Okay, pyridine leaves. Then this is converting into what in the sense carbanion. That is converting into carbanion, we can say. Malonic acid converted into carbanion. Okay. This carbanion is attacking this aldehyde or ketone. Here we can take aldehyde or ketone, we can take, but it should not have alpha hydrogen. Here we can take aldehyde or ketone, but it should not have alpha hydrogen. Okay. This we are taking. Okay. So we have taken here aldehyde we have taken. So like this we have taken. Now how the attack will be there, we'll see. This carbanion is attacking carbonyl carbon. This bond is migrating. So what we will get, we'll see what we are getting in the sense that benzaldehyde phenyl ring, that is CH, double bond O becomes O minus, then here CH, here COH and COH. Like this is produced. Okay. Next, this O minus takes H plus from pyridinium ion. Therefore, pyridinium ion becomes pyridine. The O minus becomes OH. This O minus becomes OH, we can say. Then here CH, COH, COH. Okay. What is the next step in the sense? Removal of water. Next step is removal of water from here. So how water is removed from this? That we will see. Now, how water is removed in the sense this bond is migrating, water is leaving, so that we are getting a this phenyl ring, here CH, here double bond, here COOH, here COOH. Like this we are getting. Then it is heated. Okay. Now, this is gem dicarboxylic acid. Gem dicarboxylic acid in the sense two carboxylic groups attached to the same carbon. If gem dicarboxylic acid on heating, that will undergo decarboxylation. That means CO2 will be evolved from it. Gem dicarboxylic acid. Gem dicarboxylic acid in the sense two carboxylic groups attached to the same carbon. That gem dicarboxylic acid on heating undergoes decarboxylation. That means removal of CO2. Therefore, here what is removed in the sense CO2 is removed. Sorry. How CO2 is removed here, that we'll see. This carboxylic acid we can write like this. So how CO2 is removed, that point we'll see. Now this bond is moving like this. This bond is moving like this. It becomes C minus. This H plus goes to this carbon. Okay. So this is what in the sense CO2 which leaves. So what we are getting in the sense, what we are getting, we'll see. Here phenyl ring, here CH, double bond CH, COOH. So and so we are getting. Okay, we got so and so compound. This compound we can say as this is a carboxylic acid functional group. This carbon attached to functional groups, therefore it is alpha carbon, it is beta carbon. Between alpha and beta carbons, unsaturation is there, therefore we can say alpha beta unsaturated acid. Carboxylic acid we will say as acid. This acid name is what in the sense cinnamic acid. This acid name is cinnamic acid. Here CC double bond is there, therefore it can show geometrical isomerism. What geometrical isomer it is in the sense trans geometrical isomer. Trans cinnamic acid we are getting. This is called what in the sense which reaction in the sense Novi-Nagel reaction. So for Novi-Nagel reaction, what we have to do in the sense we have to take aldehyde or ketone which is not having alpha hydrogen. We are taking aldehyde or ketone which is not having alpha hydrogen. Then we are taking a compound. In this compound, methylene group is there. On either side of methylene group, electron withdrawing groups are there. Okay, then it is treated with weak base. Weak base is pyridine or piperidine or ammonia in ethanol. Treated with a weak base, then elimination of water, then on heating decarboxylation, we are getting alpha beta unsaturated acid, we can say. Okay, sir. Next reaction will continue. Next reaction is what in the sense Beckmann rearrangement. Next naming reaction is Beckmann rearrangement. We will say we will take. We are taking a Beckmann rearrangement. Now, for Beckmann rearrangement, what we have to take in the sense we have to take oxime. We have to take oxime. Oxime, how we will get in the sense when aldehyde reacts with hydroxylamine, we will get oxime. When ketone reacts with hydroxylamine, we will get oxime. Okay, so we are taking oxime. So we are taking oxime. That oxime we are writing like this in terms of geometrical isomer. Okay, oxime we have taken. This is if you take aldehyde in the place of one R, H will be there. If you take ketone, both will be R groups. Okay, so C double bond N OH, here N is having one lone pair cell. Now we can say that this R group is anti to this lone pair. This R group is anti to lone pair, anti in the sense opposite. Then this R group is syn to this OH group, syn in the sense same side. Syn in the sense same side. This R group is syn to this OH group, you can say. Next, this R dash is anti to this OH group, you can say. This R dash is syn to this lone pair, you can say. This R dash is syn to this lone pair. Okay, sir. So we said how this oxime is there. That point we said. How this oxime is there. That point we said. Then This oxime let us treat with a mineral acid. This oxime we will treat with a mineral acid. What is the mineral acid we are taking here in the sense? Sulfuric acid we can take, or HCl we can take, or H3PO4 we can take. So and so mineral acid we are taking. So what is happening? What is the first step? In the sense, first step, H plus will attack this oxygen. Okay, oxygen is having lone pair. This oxygen contributing its lone pair to H plus. Okay, therefore between this oxygen and H plus bond is produced. Therefore oxygen, this will become oxonium ion. That will become what in the sense oxonium ion we can say. So here lone pair will be there. Then here it is becoming oxonium ion. Now oxygen will have one lone pair and positive charge. Okay. So we got what in the sense oxonium ion we got. That means what is attacking? H plus is attacking. Here H plus attacking this oxygen. Therefore this OH becomes so and so. Okay. What is the next step? We'll see. Next step what happens means. Next step you see that this R dash takes this bond and attacks this N while water leaves. While water leaves. Okay. So water is eliminating from here when R dash takes the bond and attacks here. Okay. This elimination is called anti-elimination but not syn elimination. Why is it so? This elimination is called anti-elimination but not syn elimination. Why? Because for this H2O, what is anti-group that will eliminate, that will migrate. So this R dash is anti to this, which is taking this bond and shifting to this N while water is leaving. It aids elimination of water to be easy. Okay, therefore this R dash takes the bond and comes here, attacks N, makes the water to leave. Therefore it is called anti-elimination we can say. Okay, so water has left, water has gone, anti-elimination we got. So what we will get? This RC will write double bond N, and this R dash will write N will have lone pair. Okay, N is having lone pair we can say. Now this C has lost a bond, has lost a bond. Therefore C will get positive charge. C is getting positive charge. Okay. Then the water eliminated in this step will attack this C plus, because C is having positive charge electrophile. In water, oxygen is having lone pair. Oxygen will act as a nucleophile. In water, oxygen is having lone pair, therefore it acts as nucleophile. This nucleophile will attack this C plus electrophile. So in water, oxygen is attacking this C plus. In water, oxygen is attacking this C plus, we can say. So what we will get, we will see R, C, water is attacking this. Therefore, when water, oxygen gets positive charge, then double bond N R dash. And this R dash will write. Okay. This N is having R dash. N is having R dash. Then next step. What is the next step? We'll see. This bond migrate to oxygen. This H plus migrate to this N. Okay. N is having lone pair, we can say. So now how the reaction will be there? This this H plus comes here. This H plus comes and attacks this. Okay. So R C OH. Oxygen is having two lone pairs now. Double bond N. H is coming here. R dash. N is getting positive charge. When H plus comes, N is contributing lone pair to this. N is contributing lone pair to this. Therefore, N is getting positive charge now. Okay. So next step we'll see. Next step what means tautomerism is possible. Tautomerism in the sense this bond comes here, this bond goes here. It is called tautomerism. Tautomerism takes place. Therefore, R C double bond O, this C and N double bond becomes single bond. N is getting lone pair, N is having H, N is having R dash. So and so we are getting. Okay, we got so and so. It is taken for hydrolysis in the presence of acid. It is taken for hydrolysis in the presence of acid. What will happen means this bond will break. C double bond O, single bond NH is called amide. This bond is breaking. This side OH minus we have to give. This side H plus we have to give. So it is becoming what in the sense carboxylic acid, and it is becoming what in the sense amine. That is becoming amine. Okay. This is called Beckmann rearrangement. This is called Beckmann rearrangement. Why do we say rearrangement word? For what sake we are saying a rearrangement word? Rearrangement word we are saying because this R dash takes the bond and migrates to N. It is called a rearrangement. Therefore, this reaction is called a Beckmann rearrangement. Okay. Now, this is the product. This is sorry, it is a reactant. This reactant is treated with mineral acid. We are getting this. Anti-elimination takes place. Then water is attacking. Then H plus is leaving. So you are getting this. This on tautomerism. We are getting this one. This is taken for hydrolysis in the presence of acid. This becomes carboxylic acid. This becomes amine. So, what is the reactant we have taken? R dash C double bond N OH. It is a reactant we have taken. So, what is the product that we'll see? Now, what we have to do in the sense for OH, which is anti, we have to say that anti takes N, it takes N, this N will become amine. That is a product. That is a product. This R takes this C will become carboxylic acid. This C will become carboxylic acid. That is a product. Okay. The C will become carboxylic acid. The for OH, which is anti, that group is combining with this N and becoming amine. That is a product. Okay, in the Beckmann rearrangement. So in the Beckmann rearrangement, how to say the product that we got an idea. Okay. Let us go for next reaction. Next reaction will take a Favorsky rearrangement. We'll see Favorsky rearrangement. Okay. In the Favorsky rearrangement, we have take alpha haloketone. We have take what in the sense alpha haloketone. We are taking a alpha haloketone. We are taking alpha haloketone. We are taking this alpha haloketone is treated with what in the sense alkoxide. It is treated with the alkoxide. This alpha haloketone is treated with what in the sense alkoxide. What is the product we are getting in the sense we are getting the product CH2, CH2, COO, so and so product we are getting. So how we are getting this product that we'll see the mechanism. We'll see the mechanism for this. We'll take the reactant now. We are taking the reactant. Here phenyl ring is there. Here CH2. Here C double bond O. CH2, Cl. Okay. Now this alkoxide will take, this alkoxide is abstracting proton. Now this alkoxide is abstracting proton in the sense which proton it will abstract, this proton or this proton. How do you know it? This Cl shows minus I effect. This CO shows minus I effect. Phenyl shows minus R effect. So this CH2 is flanked by two minus I groups. This CO shows minus M effect also we can say. Negative mesomeric effect. Like that also we can say. But this C is flanked by one minus R group and minus M group. Therefore, which hydrogen is more acidic? This hydrogen is more acidic when compared to this hydrogen. Therefore, benzylic hydrogen will be abstracted by alkoxide. Benzylic proton is abstracted by this alkoxide. Therefore, this alkoxide is abstracting what proton in the sense benzylic proton. So this bond is shifting here. It becomes what in the sense carbanion we can say. That becomes carbanion. So we are getting a here CH. This carbon is having lone pair negative charge. The C double bond O CH2 Cl. Sir, what is the next step that we will see? In the next step, carbanion attacking this carbon, this bond shifting to Cl, Cl minus is leaving. Cl minus is leaving. So we are getting a what product in the sense here phenyl ring, here CH, this is what in the sense CO, this is what in the sense CH2. This C minus carbon is making bond with the CH2 carbon. Okay. So like this we are getting. Sir. Now, this alkoxide again comes. This alkoxide again comes for attack. This alkoxide again comes for attack. This alkoxide will attack which carbon? This alkoxide will attack carbonyl carbon. This alkoxide is attacking carbonyl carbon, while this bond will shift. Why? Because this will become carbanion. Carbanion will be in resonance with phenyl ring. That's why this bond is shifting. Okay. So we are getting what in the sense that phenyl ring, then this CH minus, then what we can say means CH2, C double bond O, or we are getting. Okay, we got ester. Then this takes H plus from alcohol, therefore it becomes CH2. So phenyl ring, CH2, CH2, COOR. Okay, so and so we are getting. So how to say the product? For Favorsky, this Favorsky rearrangement, we are taking what in the sense alpha halo ketone we are taking. We are treating this with alkoxide. We are getting what product in the sense ester is a product. Sir. Now we'll see another reaction. Another equation we'll take for this in the Favorsky rearrangement. Another example we'll take. Now phenyl ring, CHCl, then C double bond O, CH3. It is treated with what in the sense alkoxide. It is treated with what in the sense alkoxide we can say. Now, how alkoxide is going for reaction? How alkoxide is going for reaction? Whether alkoxide is abstracting proton from this carbon or proton from this carbon. That we have to see. Before that, this compound is what? Alpha haloketone. This compound is alpha haloketone. Here CH3 is available. In the CH3, hydrogens are there. Those hydrogens we can call it as acidic hydrogens. This hydrogen is, we can call it as acidic hydrogen. This hydrogen also acidic hydrogen. Now, this alkoxide will abstract which proton in the sense? This less acidic proton but not more acidic proton. Why? Because in order to eliminate C minus. Therefore, this RO minus is abstracting this H plus and becoming ROH. So what we are getting in the sense? This phenyl ring, this CHCl, this CO and CH2 minus. This carbon is having lone pair and negative charge. Okay, we got carbanion. What is the next step? We will see. This carbanion is attacking this carbanion is attacking this carbon. Therefore, Cl is leaving as Cl minus. Cl is leaving as Cl minus. Now we can say this carbon is having hydrogen. Then C double bond O. This C double bond O is having CH2. That CH2 is attacking this carbon. Okay. so and so is produced. What is the next step? Next step is alkoxide is attacking carbonyl carbon. Now we will take alkoxide. Alkoxide RO minus will take. This alkoxide oxygen is having 3 lone pairs. It is attacking carbonyl carbon. Sorry. It is attacking carbonyl carbon. Now which bond is shifting in the sense this sigma bond is shifting to C because it will become what in the sense C minus. The C minus will be stabilized by resonance by phenyl ring. Okay, so we will get here phenyl ring, here CH minus, CH minus, then CH2, then COO or ester we got. Then this C minus takes H plus from alcohol, therefore alcohol becomes alkoxide. Now we can say that that CH minus becomes CH2, neighboring CH2, COO, so and so compound we will get. Okay, this is called what in the sense Favorsky rearrangement. Favorsky rearrangement. Okay, in the Favorsky rearrangement, next example we will take. Next example for Favorsky rearrangement. Now this is a ketone cyclohexane here Cl. It is called alpha haloketone. We can call this is as a alpha haloketone. Alpha haloketone we can say. Now this carbon we will label it. Labeling the carbon. Labeling the carbon means that carbon will have atomic mass varied from other carbon atoms. Okay, generally carbon atoms will have normal mass number or normal atomic mass. Labeled carbon in the sense that carbon atomic mass or mass number will be radioactive carbon or mass number. Okay, that's why that is called labeled. Otherwise mass number will be different, like that will be there. Okay, so now we have taken a, now we will take a alkoxide. The alkoxide is subtracting proton. Now which proton in the sense here CH2 is there, it is subtracting this proton. Okay, this alkoxide is subtracting this proton, it is subtracting that proton. Then what will happen means this sigma bond is shifting to this carbon, then that will become C minus. Here double bond O, here we can say C minus, we can say here Cl is there, we can say. What is the next step in the sense elimination of Cl minus? Elimination of Cl minus. Next step is what in the sense elimination of Cl minus. That means this lone pair is attacking this carbon, this bond is migrating. Therefore, Cl minus is leaving. So what we got in the sense we got so and so bond. Okay, between this carbon atom and this carbon atom, bond is produced. Okay, so a bond is produced. Now what is the next step we will see? Here we can say it is 5-membered ring, it is 3-membered ring, we can say. Next step is attacking of alkoxide. Attacking of alkoxide, it is labeled carbon. Attacking of alkoxide to the carbonyl carbon. So this bond can shift, otherwise this bond can shift. Okay, so we will get here for this OR will come, for this here negative charge will be there. Why negative charge is there in the sense this bond has shifted here. Okay, this carbon is carbanion. Then this carbanion taking H plus become from alcohol and become so and so compound. It is labeled carbon. Here COO or is there. Okay, What is another possibility here that we'll see? What is another possibility? Now this bond is shifting. Then what we will get? Due to alkoxide, what we'll get? We'll see O double one C bond. Here this carbon is getting carbanion. Okay, it is taking H plus from alcohol. This is taking H plus from alcohol. Then we will get like this. Okay, we got ester. So this is about what in the sense Favorsky rearrangement. Now here it is labeled carbon. This one and this one is obtained in a 1:1 ratio. 1:1 ratio because both are equivalent positions. That's why. Now we will take a Favorsky rearrangement. Another example we will take. We'll take 4-membered ring. Here we'll take ketone. Here we'll take bromine. So now we will treat this with the base OD minus. OD minus. Okay. This OD minus will do what in the sense it will abstract proton. It will abstract proton. Okay. So it will abstract this proton. This OD minus is abstracting this proton. Therefore, this bond makes this carbon carbanion. This carbon becomes carbanion, we can say. Okay. What is the next step in the sense? Elimination of Br minus. Elimination of Br minus. That means this C minus is attacking this carbon. Therefore, Br minus is leaving. So Br minus left. So what we are getting, we'll see. Here bond is there. Here double bond O is there. Okay. So what is eliminated in the sense Br minus is eliminated. Next step. This base is attacking now. That is acting in the form of nucleophile. This nucleophile will attack carbonyl carbon. This bond is shifting to this side. That will become what in the sense O minus. Okay. So what is the next step? We'll see. Now this 4-membered ring we are writing. This bond we are giving. This become O minus. OD is attached. Okay. OD is attached. This is what in the sense CH. This O minus is having 3 lone pairs. So next step is what we'll see. This lone pair is shifting here. This bond pair is shifting here. So we'll get here C double bond O OD. Okay. Next step, this carbanion is abstracting D plus from D2O. Then D2O becomes OD minus. It is abstracting D plus. Therefore, we are getting here D. Okay. This is what in the sense Favorsky rearrangement we can say. Now another example for Favorsky rearrangement we will take. Another example HC, here Br, CO, CH2R. Here 2 halogen atoms are there. In the previous case we discussed 1 halogen. Now how many halogens are there in the given reactant? In the sense 2 halogens are there at alpha carbon. So we can call this as alpha dibromoketone. Alpha dibromoketone we can call. Okay. So how the reaction takes place, that we will see. First step is attacking of alkoxide. Alkoxide will take alpha hydrogen. This is taking alpha hydrogen. So this bond is shifting here, that becomes carbanion. Here Br, here Br, then CO group, then CH2 minus. CH2 minus. Okay. What is the next step? We'll see. Next step is what in the sense? This C minus will attack this carbon, therefore Br will leave. Okay. Br will. Therefore, 3-membered ring we will get. We are getting 3-membered ring. In one case, CH2. In one case, CBRH. Here, what will be there in the sense? Positive charge will be there. At this carbon, positive charge will not be obtained. Why? Because lone pair is coming, bond is leaving. So net is what? Nothing. Therefore, positive charge will not be there. Okay. Next step we will see. Next step is what in the sense? Alkoxide attack. Alkoxide attack. So this lone pair is attacking this carbonyl carbon. This bond is migrating. So we can write here O minus and OR. Here we can write CH2 like this bond. What is the next step? We will see. This O minus is having 3 lone pairs. O minus is having 3 lone pairs. So now what happens in the sense? This is becoming like this. This bond is shifting like this. Okay. So that bond is shifting in the sense Br is leaving. Br minus is leaving. Therefore, what we'll get? We'll see here CH lone pair negative charge, single bond CH2, then C double bond O OR. Okay, we are getting like this. Next step. Next step, what happens? That we'll see. Here we can say this in this step in another manner also. What is that another manner in the sense? This bond pair comes. This Br minus leaving. Br minus leaving. Like that, can we say bond pair comes, Br minus is leaving. Br minus is leaving. Can we say? No. If Br minus leaving, this carbon gets a negative charge here. Negative, not now negative charge will be there. Only 2 bonds. This bond comes also one more bond, and the electron deficiency only will be there for this. Therefore, like this possibility not there. Like this possibility not there. So, what is another possibility? What is another possibility? We'll see. Now, this lone pair comes here. This bond pair shift here. Like this will take. This bond pair shift here. This Br is leaving. Okay. Like this will take. Here, one mistake we have done. Here, R is there, but we have written H. So that R we will write here. Here, one R group is there, that R group we will write. So, next step, here what happens means this Br minus is leaving, we are saying. Okay. So, how the product will be there? That we will see. Now, this CC bond becomes a double bond. Here, one H. This COR. For this carbon 1H, for this carbon R. Okay. Okay, like this product is obtained in this Favorsky rearrangement. Okay, now we will see what we have discussed, that we will see in the overall. In the Favorsky rearrangement, we will see phenyl group, CO group, CH2 group, Cl group. Okay, if we take ethoxide as the base, what will happen in the Favorsky rearrangement? So what we have to do in the sense, in the Favorsky rearrangement, what is the product obtained? So now we will take here CH2 pH, like this we will take. This we are taking for a Favorsky rearrangement. What we will get in the sense, understand that this CH, this carbon will make a bond with this carbon, this Cl will leave, this O will make a bond with this carbon. Okay, like this rearrangement takes place. So what happens like this? I'm saying, see, this is making a bond here, it is leaving, it is making a bond here. This is the product. This is the product. Okay, so pH, CH2, CH2, COOET. It is the product. This is the product we can say. Okay, so this is alpha alloketone. This alpha alloketone undergoing Favorsky rearrangement in the presence of a base. Okay, like this compound we will get. So now it is treated with what in the sense? Sodium hydroxide base. Sodium hydroxide base. How the reaction will be, that we will see. This O minus is attacking this carbon, so we are getting the product. So this pH is CH2. This CH2 is making a bond with CH2, then COOH. Carboxylic acid we are getting. We got carboxylic acid. Now we will treat this with RNH2. RNH2. So how the reaction will be there, we will see. This N is attacking this carbon, Cl is leaving. Okay, N will not attack this carbon, N will attack this carbonyl carbon. N will attack a carbonyl carbon. Therefore, what is the product we will get? pH, CH2, CH2. Okay, then the CO, NHR, amide is the product. We are getting what product in the sense? Amide is the product. One H plus will leave. Okay, from this NH2, one H plus will leave. So we are getting a amide is the product. Okay. Next we will see. In this Favorsky rearrangement, we will take 6-membered ring. Here one ketone, here one Cl. So now first alkoxide, treating with alkoxide. What happens means Cl leaves. Cl leaves, 6-membered becomes 5-membered. Okay, 6-membered becomes 5-membered. Then CO group will take OR minus and become ester. Then Cl minus is leaving. The Cl minus is leaving. Okay, 6-membered becomes 5-membered ring. Okay, next with the sodium hydroxide, OH minus, what happens means this carbon is taking this OH minus, the Cl is leaving, 6-membered ring becomes 5-membered ring. Then RNH2, treating with RNH2, this 6-membered becomes 5-membered. Here what will be there in the sense? Amide will be there. Here CH or amide will be there. Okay, this is about what in the sense? Favorsky rearrangement, we can say. So Favorsky rearrangement. This is what in the sense NHR. This is what in the sense NHR. That means amide we will get. We are getting what in the sense amide, CONH, amide. Amide we are getting. Okay. So in Faber's rearrangement in the sense what happens means 6-member ring becomes 5-member ring. Cl minus is leaving. Keto group with alkoxide ester. Keto group with alcohol hydroxide carboxylic acid. Keto group with amine gives amide. Okay. So like this product we are getting. Okay. Next we will go for a alpha beta unsaturated compound reaction with the Grignard reagent. We'll see alpha beta unsaturated compound reacting with the Grignard reagent, that we'll see. Okay, so we are taking alpha beta unsaturated compound. Now let us take a alpha beta unsaturated compound. Okay, this is alpha beta unsaturated compound. What compound in the sense? Carbonyl compound. Carbonyl compound means a CO group is there, ketone is there. It is reacting with what in the sense? A Grignard reagent. It is reacting with the Grignard reagent. Okay, Grignard reagent will take RMgX. What is the solvent here? Solvent is ether. Grignard reagent in the sense solvent should be ether. Okay. So how the reaction takes place here? That we'll see. How the reaction takes place. Now, this bond is migrating here. It is attacking this R dash. It is attacking which in the sense it will attack R dash. This pi bond will shift to O. This O will attack this Mg. This O is attacking this Mg. Okay. So what we are getting, we'll see. This R. Then here R dash. This R dash, this R2 dash. O Mgx. This O is making bond with the Mgx.